So welcome to Unit 1. Hopefully you checked out the welcome video where we talk more about what this three-step problem-solving technique is. But now we're going to actually put it into practice. So you'll see some more of these problems in 2A, and you're using an understanding e-text if you need more practice. What we're going to start with is a definition. Doesn't that sound just like math? So units is just what are we actually measuring or counting? We love to throw out numbers, but they really don't have a lot of value without units. Like I could tell you I was going to charge you $5 for something, but you don't know if I mean 5 cents, $5, $5,000. Like there's a lot of leeway there. So we need units for it to make sense. And our class is about math that makes sense. So in math that you need to remember your units as you go through this. Review. Remember, if you are dividing fractions or you are multiplying reciprocals, these are equivalent steps. Now, I'm not going to give you these problems where you have to divide a bunch of fractions or anything like that. I just want you to remember this as you go through and look at examples. If you lean more towards I like 8 times 4 or I like 8 times 1/4, not everyone else will work it that way, but that's okay. I want you to recognize that we are doing the same steps. Also, remember a value divided by itself is 1. This is a big idea as we look into conversion factors, and that's a big part of 2A. So that's our goal. And divided can mean, it's in this part of the fraction here and this part of the fraction there, because like we just said, multiplying by the reciprocal is the equivalence of dividing. So that's where that all wraps up together. Now, another big review is you cannot add or subtract numbers with different units. This came up in pre-algebra when you tried to add 3x and 4y. But in life, it comes out more things like if I have 2 inches and I'm trying to add that to 1 foot, that doesn't mean I magically have 3 of something, right? I have 1 foot, 2 inches. If I wanted to combine those, they would need to both be in inches, so I could say 14 inches, or both be in feet, so that I could say 1 and 1/12 foot. But we can combine units with multiplication, division, and powers, like multiplying them by themselves. So let's look at those. It'll be very important that you are able to match these keywords with what they mean. And I'm not a huge keyword problem-solving method person, and that doesn't really tend to do well in the real world, but these will help you get started. So when we see hyphens between units or we see the word of, we are talking about multiplication more often than not. So one common hyphenated unit is kilowatt hours, which just means you would take the number of kilowatts and multiply it by the number of hours. You may have seen this on a bill. Of is used in statements like 40% of $90. Well, 40% to operate in the math problem needs to be a decimal, so 0.40. Of multiplications, what we just learned, 90 is going to give us that 36. So of will be a very common statement in our parentheses, or not parentheses, our percent problems, and hyphens is something you will often see between units, just in the real world. Go look for them. Per is a fancy way of saying divide. Now, division order does matter, right? It's not a commutative property you can flip around, so it is going to be the first item divided by the second item. So what comes before per will go on the top of your fraction. What goes after per will go on the bottom. Watch out for things like that mean per in your statements. So you may have seen MPG before. That means miles per gallon. So this is the fancy way, 40 miles per gallon, of saying 40 miles divided by 1 gallon. How far am I going to get for 1 gallon? 40 miles. Wouldn't that be nice? $9 an hour or a hour means that you're going to make $9 per hour. So that's a great way to state it. But if I need to work with it mathematically, that's $9 divided by 1 hour. Notice the units have to stay with the specific numbers. So dollars is in the numerator, hours is in the denominator because of the way it's stated. Other great review, remember squared means I'm raising something to the second power. So I'm multiplying something times itself. Now, this is just something times itself, but we usually shorthand this with a squared up there. And so feet raised to the second, which we would say feet squared or squared feet. Remember, this is a very common unit for area. Area is how we cover things, and that's in squared units. Cube or cubic is a fancy way of saying raised to the third power. So this means we've multiplied something by itself 3 times. And we might say this feet to the third power, feet cubed, or cubic feet. Volume is a very common use of cubics. And so this is going to be something you're going to see in the 3D when I'm trying to investigate it that way, fill in some kind of 3-dimensional shape. Let's look at this image down here. Notice this is 12. Don't have a unit. We already know that's bad. This is 12. So if we'd say this is 12 inches and this is 12 inches, that also means that this is 1 foot by 1 foot. Why is that a big deal? Well, now you can visualize what 1 foot squared looks like. Remember, it's this area. So this entire bit right here is 1 foot squared. And I want you to see that because I want to see how it relates back to inches then. 1 foot squared is actually 12 inches by 12 inches. So this is also 144 inches squared. Now, that is where we're headed. This whole how do I convert and know those two changes. And it really goes back to maybe you know 1 foot squared is 144 inches squared. Maybe you know that 1 foot is 12 inches. We've got to start these problems where we stand. I want you to keep that in mind as we go through. So you may start problems differently than different people. You may use different steps along the way. But if you're using reasoning and true statements and doing some good math, you will end up right where we are going. All right. I like to end this with this funny little life lesson. So this is a screenshot from Reddit that's actually a picture from Walmart. This is Pamper Easy Ups, which is kind of a type of pull-up or diaper. And it's $24.94 for a 60-pack. So, looking up here though, have you ever noticed this corner part unit price that they have at Walmart? Sometimes you can compare those. But look at this dumb unit price. This says $31.18 per 100 count. That's not a great unit price. Now, it is a unit price because you see our magic new word per there. So it is dollars per items, but a better unit price would probably be per diapers. So let's say beside it, you've got some Huggies pull-ups that you can purchase, and it says that they're $22.06, and it's a 56-pack. So how could we figure out that unit price? So we could divide $22.06 by 56, right? So this is price on top, units on bottom. So this is 39.4 cents. Can we compare the two? Just like we can't add and subtract with units that are different, we really can't compare units that are different. So why would they use this? First things first. At first glance, if I'm just quickly grabbing it, 31 looks better than 39, right? Forget that they don't mean the same thing. It looks good. Not only that, you should watch out for weird units. Weird units tend to mean that someone wasn't paying attention or they're trying to pull something over on you. Not only that, this is actually a really bad idea. Someone did really bad math here. Okay, let me show you. So if this is $24.94 and you get 60 of them for that, again, I put this up here because it's price, it's per, and then it's units, and it's just in this case it's diapers. This is actually 41 cents per diaper, which means that this would be $41.56 or 57 cents per 100 count. So this is a straight up lie. Isn't that terrible? And we thought we could trust the corner. But that's kind of an idea that I really want you to walk away from this class with, is not to trust everything you see, not to trust everything you read, but to use your critical thinking and your math skills to work with what you got.